Hi everyone, today we are going to work on 6.4 notes, which is about special right triangles. We have different kind of right triangles, but two of them are special to us. One of them is the one that has 45, 45, and 90 as the angles, and the other one is this one that the angles are 30, 60, and 90. These two are special because there is a nice ratio between the sides of these triangles. And today we are going to figure out that ratio between the sides. So let's start with this one. Here I have a right triangle that the two angles here are equal to each other. If two angles are equal to each other, that means these two sides which are opposite these angles are also equal to each other. So this makes an isosceles triangle for us. So let's say here this side is 1 inch. So of course the other one also going to be 1 inch, because they're equal to each other. So now let's figure out what is the measure of this side. I can use Pythagorean theorem here to find the first side, which is the hypotenuse of this triangle. Based on Pythagorean theorem, we know that the sum of the square of two sides is equal to the square of the hypotenuse. So 2 plus 1 to the power of 2. These are the two sides, the legs, raised to the power of 2, and add them together is equal to this side. Let's call that x here, x squared. So 1 squared is 1. The other one is also 1. Is equal to x squared, and 2 will be equal to x squared. Then in order to solve for x, I'm going to take the square root of both sides, and now x will be equal to square root of 2. We know that it's basically equal to positive and negative, but we don't take the negative one, we only take the positive one. So this side is radical 2. So I can use these measure of the sides as a ratio between the sides of all the triangles which have the same measure of the angles. Any kind of 45, 45, 90 triangle that I have always have the same ratio between the sides. So I'm going to make a table here to help me remember the ratio of the sides of a 45, 45 triangle. So let's say here I'm going to write this is the measure of one of the angles, this is the measure of the other angle, and this one is the last one. 45, 45, and 90 degrees are the measure of the angles. So as I have found the sides, the two legs are 1 and 1, the hypotenuse is radical 2. So I'm going to write that here, 1, 1, and radical 2. So these are basically the ratio of the sides for all 45, 45, 90 triangles. The meaning of this ratio that you see here is that whatever is the measure of the side which is opposite one of the angles, which is 45, let's call that x, whatever is that. The other side is also going to be the same as this one. So that's also always going to be the same. And the side which is opposite the 90 degrees, which is the hypotenuse, is always the same times radical 2. So this is basically the ratio that I can always use in order to solve 45, 45, 90 triangles. Let's try that here. Okay, so in this triangle, I have one of the legs equal to 4 inch. So I'm going to make my triangle here, my table here, 45, 45, and 90 degrees. I know that the ratio between the sides in a 45, 45, 90 triangle is always like this, x, x, and x radical 2. That means whatever are these two sides, these are equal to each other, and the hypotenuse is always the measure of this side times radical 2. Okay, so what is this 4 inch? It's opposite the 45 triangle, so I can write that here in the bottom of one of these two. I'm sorry. Bottom of one of these two, so I'm going to write that here. You could also write that here. It doesn't matter because whatever is this one is also going to be the same. So right now, I know that this side is 4 inches. Now, what is the other one? It's just x times radical 2. That means whatever is this side, just multiply that by radical 2. And that's it. This is the other side. So we use the ratios to find the size of a 45, 45, 90 triangle. Now let's work on the other special triangle that we have, 30, 60, and 90. In order to find the ratio of the sides in this triangle, I'm going to use this triangle here, which is, let's say, the same as this one. And this is 60, and this is 30. And we know that this side is, let's call this one A, okay? And we know that A here is equal to 1. So I'm just going to erase this and just write 1. It's easier for us. So this is the same triangle. I draw it here. Now I'm going to use another triangle, which is exactly equal to this one, but it's just flipped. And I'm just going to put that here. So they both are making one triangle. Because this one is equal to the other one, that means this side is also 1. So basically, this whole thing is equal to 2. Now, what else do I have? Because this triangle was exactly the same as this one, well, this angle was also 60, and this one was 30. Now, these two, we can add them together, and these two are going to be 60 again. So what I have here, I have a triangle that all the sides are equal to each other. Then, because all the angles are 60, so the sides are all equal to each other. So if this one is 2, this one is also 2, and this one is also 2. So far, I figured out that if this side is 1, this side is going to be equal to 2. Now I need to find the other one, this side. Again, I'm going to use Pythagorean theorem. Sum of the square of these two sides is equal to the square of the hypotenuse. So let's call this one x for now. X squared plus 1 squared is equal to 2 squared. Okay, this is 2 squared. So x squared plus 1 equal to 4, and I subtract 1 from both sides. And from here, x squared will be equal to 3. Okay. One's a little bit nicer. Now, x squared is equal to 3. Then I take the square root of both sides, and x will be equal to square root of 3. So I figured out the other side here, and it's square root of 3. Now I found the ratio between all the sides. I can generalize this ratio for all kind of right triangles that have the same angles, 30, 60, 90. So any right triangle, which is 30, 60, 90, has the same ratio as this one that we see here. So here in my table, I'm going to write 30, 60, and 90. What was the measure of 30? The one which was opposite 30 was 1. So this one was 1. Opposite 60 was square root of 3. And opposite the hypotenuse, the one which is opposite 90 is 2. So this is the ratio of the sides between the sides in a right triangle, which is 30, 60, 90. I can generalize this again, and let's consider if a side which is opposite 30 is x, the measure of that side is x, the other one is x times radical 3, and the one which is opposite 90 is 2 times x. So I can use this ratio, the ratio that I see here, for all kind of 30, 60, 90 triangles. Let's try that here. So in this triangle, I have the hypotenuse as 8 inches. That means it's the one which is opposite 90. So I'm going to make my table 30, 60, and 90. This one was x radical 3, and 2x. The one which is opposite 90 is 8 inches. So I'm going to write the 8 here. That means 2x, the side which has this ratio 2x is equal to 8. The one which is 2x is equal to 8. Now what is x? Just divide both sides by 2, and from here x is equal to 4. So I found x. Now I'm going to replace that here. X is 4. And what is the measure of the side, which is opposite 60? It's just going to be x times radical 3. X was 4, so it's going to be x square root of 3, or 4 square root of 3. So this is how we can solve special right triangles. What we need to do is basically memorize these tables that we see here. If you memorize these, then solving all these kind of 60, 30, 90 triangles, or 45, 45, 90 triangles are going to be easy for you. So this was today's lesson, and I wish you a great day.